and welcome. I'd like to thank you for joining us for this month's Best Practices webinar. And before I introduce today's guest speaker, I just want to take a moment, because eMaint does a variety of different types of webinars. We do product demonstrations and X3 training on our product, but just want to let our listeners know this is not one of those. This is actually one of our Best Practices series, in which we invite guest speakers who are really well known in the industry to kind of share some industry best practices with you. So this is not a specific CMMS training session, but rather really a maintenance and reliability best practices. So on that note, I'd like to introduce today's guest speaker, and Remco Jonker is a partner at Mainnovation, and he's going to be presenting today's topic, Increase Your Technical Availability. Remco, are you there with me?
Yes, I'm with you, Rona.
And thanks so much for joining us, Remco. And a little background for our listeners, because I know Remco doesn't like to toot his own horn, but he has been an officer in the Royal Netherlands Navy, is an industrial engineer with a master's from Eindhoven University, and also has over 20 years experience in maintenance and asset management improvement projects. He's a former chairman of the CMMS section of the Maintenance Association in the Netherlands, but is also a regular guest speaker and chairman at international maintenance conferences, which is actually how eMaint and Mainnovation initially connected. He's also the co-author of a book that I'm sure he'll be talking about called VDM, A New Faith in Maintenance, or Value-Driven Maintenance, which is a topic he's going to be delving into today. And Remco has been kind enough, he is going to be giving away a signed copy of the book to one of our listeners today. So thanks again for everyone for joining us, and thank you, Remco, for putting this together. And just while people are chatting in, we'll give them another minute or so. Can you tell us, Remco, you've done a variety of sessions with eMaint, but this one is new to our audience, and maybe you can tell us a little bit about why you chose this topic and why it's important.
Yes, well, the central topic of today, Rona, is increasing your technical availability. Of course, in a more demanding or increasing market, so the market is asking for more products, it's very important that the output of, for example, factories, plants, is increased to make sure that you're able to comply to that demand and that you can, well, satisfy the customer. But what we see in the daily practice is oftentimes that if companies need to increase availability, they think they can, it is enough to perform an RCM study or so, or perform an RCM pilot, means reliability centered maintenance pilot. So it's about, let's say, making their preventive maintenance plans more effective. While in our experience, that is a very good exercise in itself, but that's just one element of it. It's just one item. You need to see it as a continuous improvement process, and that's in fact exactly what I'm going to highlight, which elements of that continuous improvement process should be implemented to really be successful in this field.
Excellent. Well, all right, well, before we get started, let me just take a moment with a couple of housekeeping items. And we are recording today's session, and we'll share a link of the recorded session with all of our listeners today. And we also have a brief survey at the end of the session. We always appreciate your feedback. And also, Remco has agreed to stay through the hour if need be and answer any of your questions at the end of the session. But please, if you have questions, don't hesitate to type them in the questions box in your little GoToWebinar control panel, and I'll be happy to read them to Remco at the end of the presentation. All right, so without further ado, Remco, I'll turn it over to you.
Thank you very much, Rona, for this introduction. All right, welcome everyone in this virtual room, I would say. Today we're going to talk about how to increase your technical availability, how to increase uptime. And we'll do that based on the following agenda. We will start with the focus on availability, right? That's what we're focusing on today. So we're not focusing on cost control or health, safety and environment, or SHE as it is also called. Now we're focusing on availability and how can we increase that. Then I will go into the asset utilization improvement cycle, or loop as we call it. It's in fact a plan, do, check, act loop. As I said, it's about continuous improvement, and in this part of the agenda of the presentation I will focus on the different elements of that loop. And then we'll go to some techniques, some best practices that can be applied to really increase uptime, to increase the asset utilization or the technical availability. In this presentation, that's all the same. So those three terms, let's say, refer to the same. It's all about increasing availability and also increasing output. And then I will wrap up with some closing remarks, and after that there is a Q&A session. But first let's focus on the value drivers in maintenance. So the question could be, how can maintenance and reliability add value to the overall company result? Well, in fact, that can be done in 4 ways, and that's based on the book on value-driven maintenance. As you can see, it's available in English, it's available in Dutch, and also in French. But here we look at the model, 4 value drivers. So if we're focusing on cost control, we try to lower the actual costs in maintenance and reliability. If we're able to lower the actuals with 1, 2, or 5% for the upcoming years, we will create value, right? Because we spend less money. On the other hand, if we're able to comply better to legislation, safety, health and environment, then we also create value, because then the chance that we lose the license to operate is decreased. And let's be honest, without a license to operate, there's no asset utilization, there's no manufacturing, there's no sales of any product, so there's no value creation. On the lower end, we see the resource allocation. That's about allocating resources, internal labor, for example, but also contractors and spare parts. So if we are able to lower the amount of spare parts from a value perspective, maybe there's $10 million on stock, if we're able to reduce it to $8 million, then we also create value. And of course, if we get stockouts then, because we have a breakdown and the spare part is not there, then we destruct value on asset utilization side. Today is all about the left part of this model, asset utilization, how to increase asset utilization, to increase uptime, to increase technical availability. We will go into a little bit of OEE, overall equipment effectiveness, but that's of course broader than technical availability only. Technical availability is just one segment of the overall equipment effectiveness. But as said, today we're going to focus on asset utilization. And if we drill down on this model and go one level deeper, then we will find the competencies, as VDM calls them. So on one hand, we have the asset utilization circle. So this is in fact one level deeper, as stated. On the right side, we see the cost control circle. And there in the middle, there is what we call the maintenance Aorta, reliability engineering, planning preparation, and maintenance execution. On the lower end, we will find the MRO supply chain management. That's about inventory, service supply chain management, hiring contractors, and skill and tool management, skills of people, for example. Equipment knowledge management is about data related to the equipment, technical data, but also P&IDs. So 2 circles, one up here we see the asset utilization circle, and on the right side we have the cost control circle. And the interesting thing is, if we look at reliability engineering, we got 3 inputs here from safety, health and environment. That's legislation, of course. Limitation from a budgetary perspective from the right, and it's about cost control. And from the left side we have the equipment performance planning, discussing with operations what the targets for technical availability, for example, are. And I will go into that later on. So if the right circle is important, then we need to set up the maintenance budget properly, make sure that's part of the PM program in reliability engineering, and make sure that we set up a proper cost registration and analyze that, right? But today we're going to talk about the left circle, equipment performance planning, defining targets with operations, what the technical availability should be, and translate those targets into the PM plan. Then we start planning and scheduling, preparation, executing the work. And if asset utilization is important, then we need to register our losses properly. And so we need to register downtime and also define what downtime is. Registering it, analyzing it, and that's the input for the equipment performance planning again. So there you see this Deming circle, right? In fact, the plan, do, check, act circle. And that's about continuous improvement. So today in this webinar, in fact, the central element is the left circle, the asset utilization circle. And we are going to focus on these competencies of equipment performance planning, reliability engineering, planning preparation, execution, registration, and loss analysis. That's what we're going to talk about. But before we go there, I would like to highlight that asset utilization is not always the dominant value driver, right? Sometimes it's SHE or cost control or resource allocation. How does that work? Well, let me introduce the next slide to show you that. We stole this picture from the marketing fellows among us. So on one hand we have the market volume, on the other hand we have time, and then we see in fact different phases that sometimes whole industries or products go through. A car in the automotive could go through this product life cycle, in fact is what it is. So in the first phase we talk about the introduction. Let's take a car, it's the introduction of a new car. Well, then we need to bring in the production line, right, with all the equipment. We need the spare parts to be brought in, we need the contractors, we need to train our people. And then when the production line is there, we need to make sure that we manufacture the car and that we sell it, of course. And then the focus is on asset utilization. So usually asset utilization, the central topic of today, is related to a growth market, right? The market is demanding and we need to serve the market. Then oftentimes competitors come in and a company or a product gets more competition from other cars, for example, and then the focus needs to be on cost control. Oftentimes you see then that you can buy a car with a luxurious package, for example, that you get for free just because they want you to buy the car. And at the end of the product life cycle of the car, when a new model is introduced or when well, the old model just became obsolete, then we're back to resource allocation, and then we need to determine whether we are going to reuse this production line or at least make sure that other cars can be manufactured through this production line. And as stated before, this can be related to a certain product but also to a whole industry. The chemical industry, for example, they went through focusing on asset utilization for years during the 80s. Right now they're focusing on cost control. And why? Well, because the petrochemical industry has an uptime of about 99%. There's not much to gain anymore. And also the pharmaceuticals, they started with well, earning a lot of money in the early 90s, right, with blockbusters, and the R&D was successful. The patents didn't expire that fast, and the regulatory organizations weren't that demanding, but then they started to become more demanding. The patents expired earlier and it was more difficult to get new patents too. And now they are focusing on cost control, also based on the competition by generic pharmaceutical manufacturers. Right, so yes, you should ask yourself in this virtual room, where is my company today? Are we focusing on cost control? Are we in a mature or declining market? Or are we focusing on growth? Are we focusing on asset utilization? And my experience is when I am visiting a company, nowadays I've visited well, hundreds of companies around the world, but every time when I ask this question in a certain room within such a company, I get different answers, right? While in the end, everyone should have the same answer. Everyone should know whether focus is on asset utilization or cost control or something else. Well, today it's easy. We're going to focus on asset utilization. So let's zoom in on that. And then we see the left side of the model, as we discussed earlier, that plan, do, check, act cycle. And we call it the VDM Asset Utilization Improvement Cycle. So that's the cycle of equipment performance planning, reliability engineering, planning and preparation, maintenance execution, registering our losses, analyzing the losses, and make sure that we close the feedback loop with operations and reliability engineering. Right, So we are going to focus on availability, and I also showed you that where availability or asset utilization is in the whole phase of a product or an industry. It's in the growth phase of an industry or a product. Now let's zoom in on this asset utilization improvement loop. All right, here it is again. And what kind of best practices do we apply, and what kind of best practices are we going to discuss today? Well, if we look at equipment performance planning, we have the best practice of equipment SLAs, service level agreements. More about that later. For reliability engineering, we apply the optimization of PM plans, but RCM is also part of that. Planning and preparation, we got gatekeeping as a best practice, but also peak shaving. And for maintenance execution, it will be operator asset care. For registering losses, it's the OEE registration, overall equipment effectiveness registration. For the analysis, equipment improvement teams, some of them focusing on the short-term losses, other teams focusing on the longer-term losses. And then we have also, well, TPM, Lean or Six Sigma tools. And today I will focus a little bit more on TPM. Within every improvement, in fact, the main thing is when you start is to know your targets, right? And how do we determine our targets? And then we go to the upper side, in fact, of this model. So we look at that square. That's where we're going to aim at. That is where the targets are defined. So first we have the input from SHE, from legislation, and it's just, let's say, prescribed by the law that this inspection has to be done on a monthly, a weekly, or a yearly basis, right? That's just input into reliability engineering, into the PM program from SHE legislation. On the other hand, we have the equipment SLAs, the service level agreements. So we ask production, we ask operations, okay, for the upcoming year, how much uptime, how much technical availability do you need? Is it 98%? Is it 90%, 95%? Because that, of course, has a big impact on the PM plan. And in the end, it should be a kind of negotiation between maintenance and operations. Okay, if you want to increase uptime with 2%, that will have impact for the amount of maintenance that we need to do, right? That's the tension that there is, and that's the, well, not the fight that should be fought, but the discussion that should be taken place. And on the other hand, we have limitations from a budgetary perspective, right? Yeah, we could talk about a best practice like asset-based budgeting, at least relating your budget or the expected actuals to your equipment, different equipment levels, but also to the work types, right? To the activity types like modifications, preventive maintenance or inspections, or breakdown maintenance. And when that is done properly, then, well, the whole process, and that's where the dynamics come in, continues, where you align with operations, get the limitations from finance, from the budgetary perspective, get the input from legislation, the law that prescribes activities, that's all input in the PM program, and then we need to optimize that preventive maintenance program. So that's the first step, translating the targets of operations, the directives from legislation, and the limitations from finance into an optimal preventive maintenance plan. So that's the first step. And then the second step is to use the strengths of the PDCA loop. So how am I going to make sure that I take every step that is necessary to, well, do, plan, do, check, act, right? So to do that properly, you need to, well, set the targets as we just discussed. You need to use relevant tools and techniques and best practices. And you also need to know where the losses are situated, right? So, well, a tool could be a dashboard, for example, a key performance indicator dashboard that helps you to identify where the critical failures are or what the top 10 performance killers are and the downtime causers. And then in the OEE registration, you determine where the losses are situated, oftentimes through your CMMS system or your SCADA system. And so the targets have set, the tools and techniques are chosen, and then we need to measure and monitor where the losses are. And then step 3, if we know where the losses are, then we need to reduce them. And we do that through the maintenance aorta, as we see here. Just do what is really necessary, what is really needed, and also do it with minimal resources. But the focused measures to limit and reduce the losses are in this aorta of reliability engineering, planning, preparation, and execution. And the best practices we will focus on are about the PM optimization, gatekeeping, peak shaving, and operator asset care. And that's in fact the agenda of the letter of this presentation, because I gave each of these elements a number. So we'll start with the equipment service level agreements, then go to the best practices 2, 3, and 4. We're going to the overall equipment effectiveness, look at equipment improvement teams, and then we'll end with some TPM highlights. So that's how we are going to walk through this plan, do, check, act circle with these techniques. So that brings me to the next agenda point, the different techniques. And I will, as I said, take you through these 7 elements. And the first element is the service level agreement element. And some people think that service level agreements, yes, we do that, but we only have that with contractors, right? It's a kind of an agreement between well, our internal maintenance organization and the contractors that we hire from the outside. Well, that is true, of course, but it doesn't exclude the fact that you can apply service level agreements internally too. And that's in fact what we do. Let me explain that a little bit. So first we start with the market demand. So there's a marketing and sales plan, right? And the marketing and sales guys, they talk to a production. They say, okay, we expect for the upcoming year that we are going to increase production output with 5%. Or in fact, what they're saying is we are going to sell 5% more products. And then it's up to production to say, okay, we think we are able to manage that, right? We think that we can increase the output of this plant to deliver these products. That's in fact the first step. Then the second step is that production is going to align what then the required asset utilization should be, the overall equipment effectiveness in this case, and also what the budget is that is available. And of course it needs to be aligned with maintenance to determine whether the availability and the OEE is achievable and what costs are involved, right? And that's the profession of the maintenance and reliability manager, to have that discussion with the production manager. So on one hand we have the required asset utilization, and on the other hand we have the achievable asset utilization, and that is feedback that needs to come from maintenance and reliability. And there's also a role for the reliability engineer, of course. Let me highlight that if we go there. He's focusing on the preventive maintenance program, and he should give the maintenance manager input about what is achievable or not, and that should be discussed through the maintenance manager with the operations manager. On the other hand, we have a required maintenance budget. So if production wants to increase production and we need to do more preventive maintenance, for example, then it's up to the reliability engineer to determine if we need more budget to perform the preventive maintenance. And that's also should be, let's say, a feedback loop to operations, of course. So that's a service level agreement, and usually it is written down in a document. There's an example here. It's not rocket science, but it is written down with what the targets are, what the agreements are, because you know that should also be in the agreement what the windows of opportunity for maintenance are to perform the maintenance, what the targets are related to the KPIs, and those kind of things. And with service level agreements, we strive for the optimal overall equipment effectiveness that is aligned with the targets of operations, and that is not per definition the maximum or the highest overall equipment effectiveness. It should deliver as promised to operations, so in itself that is not per definition the highest OEE. And then the SLA should be embedded in a meeting structure where the KPIs are discussed and where improvement actions are determined. So in a meeting structure, but also a communication structure. All right, so if we look at equipment performance planning, then we have this best practice of service level agreements. Let's go to the maintenance Aorta right now. We talked about reliability engineering on one hand, where the PM program is created. So we need to do that properly. Then when the PM program is ready, we need to plan and schedule the work orders. That's a very important competence. And then of course we need to execute the work in line with what we have agreed upon. And only if we do those three competencies, if we perform those competencies properly, then we are doing a good job, we are efficient and effective, and then we will create value. All right, so from a reliability engineering perspective, what kind of techniques could we identify? Well, oftentimes people think that reliability-centered maintenance is the way forward, is the way to do things. But in fact, it's only useful for highly critical equipment because, well, people that have experienced it in the daily practice have seen that it causes a lot of work to get all through it. And in fact, it doesn't apply to every situation. So what we identified is, okay, if I got a big problem and the cause is unknown, then you need to do a root cause analysis, right? That's the best practice that you apply there. In another case, if you got different problems and there is no specific maintenance plan in place, then you could apply a reliability-centered maintenance pilot or an FMEA, failure modes and effects analysis. So we got different problems. So we got maintenance history, we got failure history, we recorded some cause codes, and there's no specific maintenance plan in place. Yeah, so for a greenfield or construction and new equipment, oftentimes an RCM study or an FMEA takes place up front. But what we see more often in the day-to-day business is that the PM program is already in place, right? And that there are different problems, but as said that the maintenance plan is already there. And then we use the technique of preventive maintenance optimization. And it goes faster because you don't have to go through the whole RCM analysis, right? Because you have the maintenance plan already and you have the ability to analyze the problems that are caused in the day-to-day business. So you get data from your CMMS system, but also from the brains of your experts, right? Supervisors, technicians, reliability engineers, so they're all involved in that. So that is in fact a technique that we apply more and more, and that you know, it's just because of the fact that the problems occur, but the maintenance plan is already in place. So then the technique can be, or the RCM analysis effect can be done a lot faster, and that's called preventive maintenance optimization. So make sure you choose the right technique and make sure you avoid applying RCM to anything, only there where it is necessary. So no maintenance plan in place, or for new construction, new equipment, or when it's a really, really highly critical equipment. Okay, let's go into planning and preparation to gatekeeping. Well, what is gatekeeping in fact? Well, we see gatekeeping is making sure that not every work request becomes a work order just like that. That's what it is. So you're kind of a goalkeeper. People shoot balls at you, and some, well, you push back and some you let go through. So we got input notifications from inspections, for example, modification requests or activities for third parties. That's all input for the gatekeeping process. And depending on agreements with operations that have been made up front, whether this work request is going to create value from a risk perspective, or limiting costs or increasing uptime. If it creates value, then it goes through to planning. If not, then we reject it and we communicate that with the requester, right? That's in fact what gatekeeping is all about. And the gatekeeper role, it's a central role. Usually the gatekeep meeting takes place every day in the morning. You know, the gatekeep meeting at around 7 or 8, and then the an operations representative, we call it the asset owner here, the asset manager or the maintenance manager is there, the reliability engineer, and also the gatekeeper himself, of course. And there it is determined whether the list of rejected work orders is justified, and also the list of work orders that are going to planning are justified. So that's gatekeeping, a pretty simple best practice, but very effective. And the company DSM was able, it's a chemical company, was able to reduce the workload with 70% because of the application of proper gatekeeping. To do that properly, they defined a risk matrix that was set up together with production, with operations, and the gatekeeper challenged each work request against that matrix. And then the outcome was, yes, we're going to do this or we're not going to do this. And I need to say that the workload was reduced with 70% without decreasing technical availability or jeopardize sheet legislation. Right, that's about gatekeeping. Let's look at some process steps. So we have the input from notifications, from inspections, modifications, also activities from third parties. That goes into the gatekeeping, and some of them will be rejected. Others will become work orders that go to planning. But we also have the input from the preventive maintenance program, of course. But those work orders we need to do anyway, right? Because that's why they're in the preventive maintenance plan. So the input for planning is coming from the CMMS system, released work orders, and from the gatekeeping role. And then after the planning, we start scheduling, distributing the work, and also executing the work. And oftentimes the execution of work is, well, made a bit more complex because of the breakdown input. And there we see exactly how this works. The planning process can be disturbed by breakdowns. And the more breakdowns you have, we all know, the more challenging the whole planning and scheduling work is going to be. And the more scheduling it will be to utilize your technicians properly. Okay, so that's about gatekeeping and the maintenance Aorta, you know, reliability engineering, planning, scheduling, execution. Let's focus a bit more on planning and scheduling and the peak shaving best practice. So peak shaving, it's more about the scheduling. It's about, okay, we see that the upcoming week or the upcoming month, we have a certain workload that we need to digest, right? There's a certain work in hours that we need to perform. And well, then we need to challenge that or check that, match that with the internally available capacity, right? And if we see that the amount of work is higher than the internal capacity, well, then we need to react on that and determine what can be outsourced or what, well, you know, what should be done in-house. So there's a big relationship there between, let's say, distributing the workload across the internal organization and also the external organization. And if you look at a shutdown, then you have a very high peak, of course. So then, of course, there's a lot of outsourced activities too. So the role of the planner and the scheduler is, in fact, to egalize that workload as much as possible and shaving the peaks where necessary. So here we see that role of the planner and scheduler, in fact, in the central service desk. So he contacts contractors, he is aligned with production, he distributes work to the technicians, to the blue collars, and also is in contact with the reliability engineer about the performance, the execution of preventive maintenance. All right, this is about planning and scheduling. Now we go one level lower to the maintenance execution. It's the other competence of the maintenance Aorta. And if we look at the best practice there, it's operator asset care. First step in operator asset care is to make sure that the targets are set right and that the operators are trained properly. It sounds really simple, but oftentimes the step of training them properly is forgotten or not done, and that's, well, a guarantee to not be successful, I would say. So training in this matter is very important because they need to understand that they are the owners of the equipment, right? Then the next step could be cleaning, get rid of abnormalities and visual access, make sure that everything is easy accessible and that the equipment is clean, because then you see much faster and easier if there are things wrong, right? If there are any abnormalities. Then repair what is not good on the equipment. Are there any MacGyver solutions, right? And replace, so make sure that the equipment is in a good health. And then develop the checklists and the one-point lessons, and also create the tags, that can be put on a certain failure. You put on the tag, and then that should be repaired by a technician in this case. And the last step is visualize what's happening by a team board, and also measure KPIs to close the feedback loop, right? Because we are determined to do plan, do, check, act. That's what it's all about. So now we went through the maintenance Aorta. We highlighted the best practices of reliability engineering, planning and scheduling, planning and preparation, maintenance execution. Now we go to the left part of the circle. It's about loss registration. And there we talk about the registration, in this case, of the overall equipment effectiveness. In manufacturing environments, oftentimes this figure is used to calculate the output, in fact, of a plant. And it consists of 3 elements. It's very hard to compare the OEE between companies, because some companies say, okay, 100% for us is 1 year, 24 hours a day, and we exclude the weekends, for example, while another company is only looking at the amount of production days. And then they call that 100%. But the OEE calculation consists of 3 elements, as said. The availability rate, so that's related to technical availability, for example. The performance rate, as you can see here in this picture, and the quality rate, and so how many defect goods did I have, so those are also losses, of course. Then these 3 figures are multiplied with each other, and that ends up to the overall equipment effectiveness. Now, there are different ways of doing that. This picture shows how a certain paper company is doing it, and they have some different losses defined, as you can see, but it's just another way of measuring the same. Well, and if you are measuring your losses, then there are 2 ways, in fact, to deal with that and to start up improvement activities. One is the short term. There we talk about the plan, do, check, act lists, and more about that later. And we also have the long term, and then we look at the top 10 performance killers or availability killers. And the short term is oftentimes merely analyzed by supervisors and by operations, while the long term, availability killers or performance killers are analyzed by, yes, you could guess it, of course, the reliability engineer. All right, so let's dive into these OEE components through this picture. Well, what we try to do, of course, is to increase the green segment as much as possible. That's the actual efficiency. In this case, the 100% consists of the actual efficiency and the different losses, and the red one is the loss due to no market demand. And that is something that cannot be controlled, of course, by maintenance, but the downtime, of course, can be controlled by maintenance, and especially the 3 ones up here that are related to availability. You see it here. Changeover oftentimes can, well, only partly be influenced by maintenance, but it's mainly here about scheduled and unscheduled downtime. Let's take the transition losses and changeovers into account too. Main thing is that we increase the green segment, right? That we focus on that. Okay, but to do that we need to analyze the losses, and as said, there's a short-term way of doing that through PDCA lists, plan, do, check, act lists. Oftentimes a kind of Kaizen team is focusing on that. That's merely related to production, so people from operations are in the lead here, lean representative, maintenance technicians, and basic tools are used like the 5 whys, and then the real root cause should be identified, and then the improvement action can be taken. On the other hand, before we go to the longer term results, I would like to highlight this best practice, I guess, from an automotive company in Spain. They use this whiteboard in their meetings, their production meetings, and in fact they are not allowed to use PowerPoint. They think it's a loss of time, talking about losses, they think it's a loss of time, so they only use whiteboards, and the last 10 minutes of each production meeting, one person who is volunteering is able to have a 10-minute talk about a description of a problem that he or she has found, what the cause is of that problem, what solutions have been provided on a temporary basis, and what solutions are identified on a definitive basis or a final. It should be a longer term solution, and also what kind of implementation impact there is. And well, they were very successful in this. Right now there is even a waiting list to participate in this meeting, while in the beginning, before this started, people didn't want to participate in the meeting. And the thing is, you could say, okay, this is a whiteboard, so what happens with this information, right? Because it's not available. What they do at the end of the meeting, they make a picture of this whiteboard, they tag it with words that help you to find it when you search a certain database, and then they just save the picture. That's how simple it is, and that's how easy they process this. So this is a easy to implement best practice, I would say, and it's also even possible to well, to find it back and to search for problems that occurred earlier, and also solutions that were provided. That's a very nice best practice to solve these short-term problems through the PDCA lists as we discussed. So back to the loss analysis and the longer term. There we talk about the top 10 analysis of performance killers, for example. Then the maintenance team is in the lead with maintenance representatives, engineering, also production, supplier, the contractor or the original equipment manufacturer, and then techniques like reliability-centered maintenance are used, or DMAIC, that's define, measure, analyze, improve, and control. So when we see this, sometimes we have an operations manager, well, sometimes that based on his gut feeling or belly feeling says, I want this equipment to be analyzed. So in the end, to do it properly, we need facts and figures, and that's also why we need dashboards, and that's why we need to measure what is happening. So look at the top 10 breakdowns from a duration perspective. So the impact on downtime in minutes, and on the right side we see it in amounts of work orders. Other ways of identifying the priorities is a picture like this, where you see the cost drivers related to the performance killers. And so the top right segment is where you should not be, because each dot is an equipment, but the equipments there in this segment, right, have high impact on downtime and also cost a lot of money to repair. So those are the high priority equipment that we would like to focus on. And another way of doing that is looking at the downtime versus the failure rate. So also here the top right segment, there the failure rate is high, so a lot of failures, and also the impact on downtime is big. So those are in this case the high priorities. Just a few techniques to set priorities, so which equipment are we going to tackle first. Right, that's about the loss registration. Now we continue to the analysis, also partly loss registration. We're focusing on TPM. Yes, there are different pillars in TPM. The only reason why I show you this picture is to show that maintenance is only one of the pillars of TPM. That's one element, and the other main element, in fact, of TPM is continuous improvement. A big thing in TPM is the power of zero, meaning 0 injuries, 0 accidents, 0 defects, 0 breakdowns, and 0 waste. And to highlight why that is important, I would like to show you this example, the power of 0. So we have this organization, Company 1. In 2012, they have a defect rate of 5%, and the goal is 0%, while Company 2 has a defect rate of 2.5%, and the goal is 50% reduction. Right? So you could say that Company 2 in fact is doing better in this case, because the defect rate is only 50% of Company 1, right? Okay, so now we're going to set targets for 2013, and then Company 1 has set 0%, Company 2 says 50% reduction, and Company 2 in fact has been able to reduce the defect rate with 50% to 1.25%. And company 1 has been able to reduce it to 1%. And why is that? Well, because they were trying to reach the goal of 0%. So you could say, yes, company 2 reached their goal, but in fact we understand that company 1 created more value, right? Because their defect rate from an absolute perspective is better performing than company 2. So that's how TPM highlights and undescribes the power of zero. Another best practice in TPM is visual management. This is an example. We all know the red-green best practice of pressuring and temperature meters, right? If it's green, it's okay. If it's red, it's not okay. But a best practice that I don't see that often, but when I was responsible for a manufacturing plant, we always had a lot of challenges with, let's say, starting up after a shutdown or a turnaround. And to cope with that, we developed this, right? So the green code of a valve, then it was open during production. When it was red, then it should be closed during production. And when it was white, the valve should be adjusted depending on the production situation. So at a glance, you can see when you are starting up production again, whether a valve is in the right place or not. And it's important to be effective in starting up as soon as possible and not waste any time there. Another example we see here, checking without touching it, right? That's what we see here. And also indicators like this in an area where you have a rack and where fork lifts, for example, are driving around, then it's useful to have a system like this, to have two red tapes on either side to see if everything is still in place. Or on the right side we have the indicators that is in fact the same, and there you can see when it's okay, right? Then the red stripe is totally red, and here it's not okay. Then there's a difference between this side, of course, and that side. And another example is a turning table, and from a distance you can see if it comes back into the right position, right? You see that here with the OK is green, alarm is orange, and then red is not okay. And then the last one, I like this one, it's about lifting. You can see that here with the yellow mark. So here part of the production line or the equipment is lifted to be able to clean below the production line, but also to perform a visual check easier. And on the right side we have a cover plate that was iron before, but then was replaced by transparent plastic to make sure that we can see what's happening down there. Keep it visual. Sometimes it's very easy to pick this low-hanging fruit, I would say. All right, so these were some techniques, best practices that can be applied to increase asset utilization. We have discussed these different techniques, but the main thing in fact is that the process of increasing asset utilization, increasing uptime, is all about continuous improvement and about closing the plan, do, check, act loop. So let me highlight the power of continuous improvement shortly. All right, so if I want to increase performance in time, I can make an improvement step. We see it happening here. And then if I'm lucky, the organization stays on the same level, right? But what we will see is that if you are not improving yourself continuously, then the best practice or the maturity of the organization will deteriorate. So the innovation will go down, as you see here, without continuous improvement. But if you implement continuous improvement, then you will improve during each step. And the good thing about that is that you see that in the end, well, in the beginning, the impact of the continuous improvement doesn't seem to be that big, but at the end you can see that the improvement gap in fact is significantly. So this is the reason why organizations that are really able to implement continuous improvement properly, plan, do, check, act, that they really outperform companies that don't do that. An instrument that is needed to implement continuous improvement is, for example, a KPI dashboard, because then you can analyze what's happening determine where there are deviations and identify root causes. So in this case we see the competence model of value-driven maintenance built on top of SAP or Maximo or Infor-EAM or Oracle, any system, eMaint. And if you drill down on asset utilization, that's the KPI of technical availability, for example, you drill down to the dashboard where every performance indicator related to availability is available, and then you drill down in the end to the lowest level, the level of the work orders. And the thing is that we spend a lot of money in systems like eMaint to register and record work orders, but what are we doing with it? Do we roll up all this information to a key performance indicator that helps us to see where deviations occur and to analyze what the root causes are? Well, we see the trend that it's done more and more, but we're coming from a long way. So many companies still use their CMMS system as a kind of electronic Rolodex, an electronic card box, instead of using it as a maintenance management system. So an example, if you would drill down on this, this key performance indicator of technical utilization here, then you get into this dashboard of the technical availability, the top 10 breakdowns from a duration perspective, amount of breakdowns, and here we see these very interesting graphs of performance killers versus downtime in this case, and here we have the performance killers versus the cost drivers, but we've discussed that already. Right, that brings me to the end of my presentation and to the end of this webinar. I hope I have been able to show you that focusing on technical availability is not about applying RCM only. It's about implementing a continuous improvement loop. We call it the VDM Asset Utilization Improvement Loop, a plan, do, check, act loop, where you set your targets first, right? Then make sure that the improvement loop elements are in place, so the registration of losses, the tools to analyze properly, and then you should be able to use the right best practices to initiate improvement measures. And that whole package, these 3 steps focused on this improvement loop, should help you to increase availability properly. So now there's time for any questions.
All right. Well, thank you, Remco. That was certainly highly informative, and we did get several questions coming in. I do want to let our listeners know also that we will be sharing, there was such a wealth of information, we will be sharing a link to the recording if you would like to go back and revisit it. We did have someone ask early on in the presentation when you were talking about the planning and scheduling function, Remco, for your thoughts on centralized versus decentralized. Apparently this plant has just implemented decentralized and is having some challenges, and can you just share any thoughts or insight regarding the advantages of centralizing and decentralized?
That's very interesting, and I got an answer to that. So the question is, if you look at planning and scheduling, should that role in itself be centralized or decentralized? And the answer is pretty easy. The answer is it doesn't matter. It doesn't matter. And I will highlight that with an experience I had within the Volvo Cars environment. I was doing a big program, a global program within Volvo Cars to set up the whole maintenance strategy, to harmonize the maintenance processes, and also to implement a standardized CMMS system. To do that properly, they wanted each plant, each site to speak the same language, and that's why we defined the process blueprint, best practice process blueprint. But we also set up organizational roles. So the main thing is that each site still had the opportunity to define the organizational setup themselves. So the CMMS system was standardized, the processes were standardized, the roles were standardized, but the organizational setup was not standardized. So what does that mean? Because the organizational setup is not the same as the role definition. No, it's not the same. So for example, in the Hövde plant, that's the engine factory in Sweden, there the planner and scheduler function was completely centralized, meaning that a white-collar person was doing the planning and scheduling behind the desk. But the role was still the role of planning and scheduler. While in the Ghent factory in Belgium, the role of planning and scheduler was performed by a blue-collar technician, in fact, within the operations team, completely decentralized. Well, I can tell you both plans are best practice. They achieved a very high availability. In the Ghent plant, they achieved an availability of 98.7%. Because of that, the maintenance manager became maintenance manager of the year. His name is Mark Bergijn in Belgium in 2013. So they produced 250,000 cars a day with 828 robots. It's an amazing complex facility, and they have a technical availability of 98.7%. But as you see when I share this, the role of the planner and scheduler is completely decentralized, while in the end the role of the planner and scheduler in the engine factory in Sweden was centralized. In fact, it was not specifically about the organizational setup. Why these plans were successful is because they really were able to implement continuous improvement. So the answer to the question is, in fact, it doesn't matter, but whatever you choose, make sure that the role is performed properly.
That's great. Great insight, Remco. You also mentioned about how important it is to track equipment downtime, and typically who is responsible for entering this data? And in your experience, I mean, I know we can share it in a CMMS, but can you share about who is generally responsible for making sure that that data is tracked?
Yeah, well, that's a good question too. So the downtime, where is it coming from and who's responsible for recording it properly? Usually if you talk about quite a complex plant, then the downtime is recorded by operations through a separate system. Recorded by operations through a separate system. And why? Well, because they record the total downtime, and they want to measure and record the whole overall equipment effectiveness, while maintenance is only responsible for part of the OEE. So what we oftentimes see is that the total recording takes place in a separate system, and that the technical side of it is validated by maintenance either through a separate tool or through an interface with the CMMS system.
Great. Okay. I think we have time for a couple more quick questions. What is the best process in your experience, Remco, to determine the remaining predicted life cycle on a piece of equipment in order to plan for the costs to meet the SLA? So I gather this listener is asking about when equipment is, more mature. Mm-hmm. How do you determine what's in its remaining life cycle? I don't know if there's a short answer, but any insight is appreciated.
Yeah, well, that's not an easy question, I must say. Then we talk a little bit more about asset management instead of maintenance only. Of course, through condition monitoring, you can determine what the health of a certain equipment is. But in the end, it's also about more like a helicopter view, determine what the age of a certain equipment is and what the remaining lifetime is. But the lifetime is well related to the economic lifetime, but there could also be another lifetime. It could also be the product lifetime itself, for example. So there are different ways why an equipment, or reasons why an equipment becomes obsolete or not. And the challenge is that you determine what the age of a certain equipment is and how much money has been spent on maintenance. And then the question comes, okay, if we want to replace this equipment, is that the best way forward, or should it be a lifetime extension? And that depends, of course, at the age of the equipment, the amount of maintenance that you have put in, and also the amount of improvement projects that you have put in. So right now, we are in the process of writing the successor book of value-driven maintenance. That book will be more about asset management, and the central topic of that book would be exactly this: determining what the age is of an asset, what the health is of that asset, kind of sanity check of the asset, and whether it is delivering the most value to replace the asset in time, or to keep on maintaining it, or to do a lifetime extension.
Excellent. Well, thank you for that. Is a succinctly stating that was a great explanation, and also a great explanation, as one of our listeners pointed out, on planning and scheduling. And I think we could go on for a very long time, but I want to be respectful of everyone's time. So I would like to thank all of our listeners for joining us today, and thank Remco and Mainnovation for putting this together. And again, this is Rona from eMaint, and we really want to create content that is of value to you. So we do have a very brief survey at the conclusion of the webinar, and please let us know how we did, what other topics thought leaders such as Mainnovation and others can present that will really help with your own continuous improvement and reliability journey. So on behalf of eMaint and our listeners out there today and Mainnovation, thank you all, and thank you, Remco, for putting this together. And we'll send everyone an email. We'll tell you about some upcoming sessions. And again, if you have more questions, there's Remco's information as well, or respond to the email you get from eMaint, and we'll continue the dialogue. But thank you, Remco.
Thank you very much, Rona, and thank you very much, everyone, for your time out there in the virtual room. I hope it was valuable, and I hope to see you and meet you on one of our next webinars.
Okay, thanks so much. Take care, everyone.